Hello students, today's agenda is to check homework. We'll be able to do length to area proportions and you will be able to do 11.10. Today students will be able to use square proportions of areas to sides or from sides to areas. So I'm going to do it a little bit different. I know that some others books and teachers show it with what is called the proportions. I do want to show you what the proportion is, but I'm gonna do just step by step of what's going on. So let's say that I have two squares. The length of the side is 3 meters for one, and then the area is 9 meters square. So if the length of the other is also 3 meters, what's going to be the area? So the area is going to be also 9 meters squared, just because they're identical. But notice what happens when you're doing something different. So in here, the length is 3, but in here is double. Okay, if you double the length of the side, does this double as well? Well, let's see. 3 times 3 is 9 square meters. In here, it's going to be 6 times 6 is not 12. I mean, it's not 18. It's not double the 9. But rather, 6 times 6 is 36. So the area, or x in this case, will be 36 square meters. So the 9 didn't double. Instead, it was 4 times as much. Why? Okay, if it doubles, okay, if you multiply by 2, in here I had to multiply by 4. Interesting. The next one says, oh, let's triple the length. Okay, so 9, is it going to be triple? 3 times 9 is 27, but let's see what happens. 9 times 9 is 81 square meters. So no, it doesn't triple. Instead, what does that do? Oops, 81. Okay, 9 times 9. So in here, it tripled. In here, it was multiplied by 9. And what I want you to notice is that in reality, what's happening is that if this multiplies by 2, I'm sorry, then when we square that, we get the relationship between the areas of the two squares. If this is times 3, then we square that, and that's the relationship. 3 squared is 9, so that's the number that we're going to use to multiply to get this area. Okay? Again, these are length to length and then area to area. So for the length, you multiply by 3. For the area, you multiply by 3 squared. And let's see how that shows in something a little bit bigger. So in here, and it has explanation already, the sides are 10 times as long. Okay, so you have 3 times 3 is 9, but then 30 times 30 is going to be 900. So what is the proportion from here to here? What do you have to do? We multiplied by 10. So for the 9, to get to here, we're going to multiply by 10 squared. Remember, this is area, so it's squared. So for the areas, it's 10 times 10, so it's 100. Okay, so 9 times 100 is 900, so that's the area in here. So x, or area, is equals to 900 square meters. Okay, and the proportion is 1 to 100, so that's what we're multiplying. So this is the relationship that I want you to see. The length, and how do I find that? That's another, we're gonna be using those steps. To find this 10, I divided the big one by the smaller side. Okay, so let's start building some rules in here. The first step that I did was to divide, or how to find that 10. I divide the big. So step 1, divide big by small one. Okay, again, there are other videos that you can search which do with the actual proportion. Okay, but I'm gonna divide the big one by the small one. The second step is that you're going to either square or take the square root. Okay, you're going to raise to the second power. If it goes from length measurements to square measurements, you're going to square it. But if we'll see that sometimes you're going to have these two values and you're going to have to find one of the lengths. So you're going to take the square roots. Okay, so that's the second step, to either square it, square that number that you found in number 1, or take the square root. And it will make more sense when we apply it. And the third step is either to multiply. So if it's the small, and then times the value, okay? Or if you have the big value, then you're going to divide by whatever you found in step 2. Number or value from step 2, okay? So whatever number you find in step 2, we're gonna use it. Okay, let's apply, because maybe it doesn't make sense right now, but it will once we start using it. Something else that I wanted to show you is a diagram that I did similar to this one, but that shows why is it that you don't double the area, you don't triple the area. And this is the reason. Because in here you fit only one of those squares in here, but in here you don't fit only 2 squares, you fit 4 of those. In here you don't fit only 3, you don't triple the area, you fit 9 of those. Okay, because you're not only doubling the length, also the height is doubling or tripling. Okay, so in here you double the length and double the height. In here you triple the length and triple the height. Otherwise it would be like this and it wouldn't be a square anymore. Okay, if you triple only the area, then you're not tripling the height, only the length. And so that's why it shows that relationship. Okay, so now let's put it into practice. And so here is an example. Hopefully you can see it. Maybe I'll zoom in a little bit and go back and forth maybe. Okay, so the first thing is to divide. We'll look at the values. You have 2 different figures, and it doesn't have to be a perfect square to find proportions, okay, in areas and lengths. So you have the lengths of these 2 shapes. You're missing one of the areas. So the first thing is that you're going to divide the big one by the small of what you have. So 6 divided by 3. 6 divided by 3. And that gives me a 2. So you're going to put it in here, 2. Now, the other thing that you need to notice is that, did we multiply 6 times 2 to get 3? No. So we divided, right? And so, because we divided, or actually, this is going to help us to clear that more. Since we have length, then we're going to take the square of that number. So we square the 2, and 2 times 2 is 4. Finally, if what we have is the small one, we're going to multiply by the number that we found in step 2. But if we have the big value in the area, we're going to divide by this number. Okay, in this case, I don't have the area of the big one. I have the area of the small one. So what am I going to do? Divide or multiply? The small one, we multiply. And so we're going to multiply those two values. 4 times 20 is 80. So x is equals to 80 square centimeters. Okay? Again, first step, divide big by small. So 6 divided by 3 gives me 2. The next one is, and don't pay attention to this. So just 6 divided by 3, 2. The second step is that if you have lengths, because that's what we had, then we're going to square that unit. So 2 times 2, 2 squared is 4. Okay? And the last step is to, since the value that we have for the areas is the small one, we're going to multiply those two values. Okay? And 4 times 20 is 80. So hopefully with more examples, it's going to be better and better understood. Okay, so, and it's going to change sometimes. So this little table or steps is going to be helpful for us. Okay, again, we have length. We're missing one of the areas. And so again, what we're going to do is divide the big by the small. So it's 16 divided by 12. And in this case, we're not able to divide evenly, so we're going to simplify. So both are divisible by 4. We're practicing our fractions here. 16 divided by 4 is 4. 12 divided by 4 is 3. I'm sorry. And remember, it doesn't matter if the big one is not at first, it's second, that's fine. We're going to put the value here, 4/3. Now, excuse me, since we have lengths, we're going to square the unit. So this square is going to be 4 times 4 is 16. 3 times 3 is 9. And that's the second step. Okay, we squared it because we have lengths. This is only if we have areas. When you have areas. Okay, but right now we don't have the areas, we have the lengths, so we're going to square it. Take the square of this. And so now it's not going from the small to the big one, it's going from the big to the small. So what are we going to do if we have the big one and going to the small? From the big we divide. And so 72 divided by 16/9. Again, practice of fractions. We put it over 1 and then we go like this. We multiply across and the answer bounces. Okay? Or you can do the multiplication of the reciprocal. Either way is fine. So 72 times 9 is 9 times 2 is 18, carry 1. 9 times 7 is 63, and 1 is 64, divided by 16. Okay, and for that one, I'm going to use my calculator. I can do it long division, but just to make the video not so long. So it's 40.5, or it would be also 81/2 if we simplify and simplify. Okay, so 40.5. And so that's going to be the value of x. X is equals to 40.5 square centimeters. Now let's see if it makes sense. Well, we know that this is a small shape, smaller than this one, so it's accurate. Okay, and this means that this is 4/3 of whatever this is, so it's about that. Okay, well, it's actually that. Okay, let's do one more. Okay, here, what do we have? Again, divide. We don't have the lengths, if you notice. We have the areas. So we still divide. Step number 1 is always the same. Divide the big one by the small one. So 99 divided by 44, and I think I just want to leave it as a fraction. 99 divided by 44. Both are divisible by 11. Here we are reducing or simplifying actually fractions. 99 divided by 11 is 9. 44 divided by 11 is 4. So that's the comparison or relationship between the areas. Very important. So you have areas. When you have the areas, what are we going to do? We're going to take the square root of that relationship between the two shapes. Okay, we're going to take the square root. And what is the square root of 9? Well, it's 3. What is the square root of 4? The square root of 4 is 2. And so, the next step, we already took the square root, found the number. Then the next step is, look, do we have the big one or the small one? We have the big shape. And you can notice because this is bigger than this one. Okay? So if you have the bigger shape, what are we going to do if you have the big one? We're going to divide. That's the third step. Again, the first one is to divide the big number, the bigger by the smaller one. That's what we got and reduced it. The second step is to either take the square or the square root, depending on what we have. We have areas in here, so that's why we're taking the square root. So we took the square root of the relationship between the areas, we put it in here, and that's the relationship of the lengths. Okay, remember that this is always squared for the areas or vice versa. And so now we're either multiplying or dividing. Since we have the big one, we're going to divide. And so 6, can we see in there? Yeah. I'm going to cover it a little bit, sorry. 6 divided by the relationship that we found is 3/2. We put it over 1. Let me show you the other way of, remember that you can just multiply, okay? The answer bounces. So let me do it both ways so that you can also, maybe you are more familiar with the multiplication of reciprocals. So 6 times 2 is 12. 1 times 3 is 3. And then 12 divided by 3 is 4. So this measurement here, the x, is equals to 4 centimeters. Now, because it's a length, we do not put square. It's just like that, okay? And so let me show you the other way of this division. So we're still dividing. So it's 6 divided by 3/2. But then some books show that you keep the same for the first one, put it over 1. The division becomes multiplication, and you use the reciprocal of 3/2, which would be 2/3. For multiplication, we always multiply straight. So 2 times 6 is 12. 1 times 3 is 3. And 12 divided by 3 is 4, which is the same. Okay? Okay, you want some more? Okay, let me do one more. Now, what if we're using exactly the same example, but instead I erase the area so that you can see the difference between having the two areas and having the two lengths instead. So it's the same example, but in fact, you already know the answer for that one, but it's just so that you see the difference between the two steps, okay? Okay, first step is the same. Divide big by small. So in here it's going to be 6 divided by 4. 6 divided by 4. I'm trying to avoid that little sun spot. And we simplify. Both are divisible by 2. So the reduced will be 6 divided by 2 is 3. 4 divided by 2 is 2. Notice how that is the relationship of the lengths already in here in this one. Okay? So that's the relationship of my lengths. The next step is that if I have the length, what am I going to do? Square that relationship. Okay, that's how we find the relationship of the areas. We're going to square it. And 3 squared would be 9. 2 squared would be 2 times 2 is 4. So this is the relationship for or between the two areas. The next step is to either multiply or divide. Well, I have the big area. If I had this one, then I would multiply. But since what I have is this one, I'm going to divide. Okay, I'm going to divide. And so 99 divided by, 99 divided by 9/4. You put it over 1. And the same thing. 99 times 4 is, 9 times 4 is 36. 36, carry 3. 9 times 4 is 36, and 3 is 39. 1 times 9 is 9. And then how many times, this is direct division, okay? Let me see if I can get some more, whoops, bad idea. A little bit more light in here, but not that much light. Okay, sorry, I just ruined it. Okay, so direct division is how many times is the 9 going to 3? It doesn't go. 9 into 39, 4 times, and 9 times 4 is 36. To 39, 3 more. How many times does the 9 go into 36? Now I take this as a new number, and it goes 4 times. So that's the answer, and so x is equals to 44 square centimeters. Okay, that's the area of that. Okay, if you want to learn more about direct division, you can go ahead and ask me, or you can use your calculator, or you can use this method instead, long division. 396. How many times does the 9 go into 39? 4 times 9 is 36, which is what I did. But then when I subtracted, I put the 3 in here. Okay, it's right there. Bring down the 6. That's my 36 right there. And how many times does the 9 go into 36? Is 4. That's the second 4. So basically it's the same thing. It's just that you're doing everything right there. And the bringing down is right there already. Okay. Okay, with this you're able to do 11.10. But remember these tips. These are going to help you and guide you through the process, okay? So have fun.